Okay, this is part two of the March 23 Dallas Personal Robotics Group monthly meeting, and I just want to quickly advertise some upcoming events for the next series of monthly meetings. April 27th, and we switched the monthly meetings to the fourth Saturday, so it'll always be on the fourth Saturday, and always be in this room. Except for Roborama, which I'll mention in a second. April 27th, Brady Pamplin is going to talk to us about PCB building, how to get yourself, I think, 5 PCBs for $2. And then May 25th, the monthly meeting will be dedicated to Roborama practice. It will be in this room. Roborama itself will be on June 1st, so that's the following Saturday, and it will be in the back room. What do they call that conference room? The interactive conference room. For all these meetings, we will have the doorbell out front, so you can ring it to get let in. And then June 22nd, I'm very excited. Bob Cook, who's a Robo Magellan master up in the Vancouver area, is going to do a remote presentation on a topic that was broadly requested at the February members meeting here, which is the topic of training AIs to recognize stuff, specifically cones. So he's done, I saw his December presentation to SRS, and he did a really interesting, great job of, how do you train an MI? How do you do ML, train an AI to recognize cones? And he's got a good, so he's going to present that with his future advancements that he'll have by June. And okay, comms team. One of the requests from last meeting was to enable members to more easily communicate with one another, and so we charted a comms team at that time, which was, and so I appreciate their help with work that's gone on over the last month. Steve Edwards, Raj, and no, Carl wasn't on the comms team. Raj, Steve, and Harold Pulcher, and then we subsequently pulled in Kareem. And so I want to share with you, we did an investigation into how can we get members able to communicate with one another, and we looked at various platforms. We selected 4 of them for detailed evaluation, which was Google Groups and Groups.io for an email replacement for our current listserv, and then Telegram and Discord for a chat platform. We rejected several others, including Discord, Slack, Teams, WhatsApp, Facebook, for various reasons. So out of the 2 of them, so out of the looking at drop-in replacements for listserv, for our current listserv, we ended up recommending Google Groups. We had a comprehensive rubric that we now analyzed them by, and we also built implemented instances of each of those platforms and communicated with one another using them. And so we ended up settling on Google Groups. And so it's got a kind of a modern look and feel to it. Anyway, that's a test implementation that I hope we'll be rolling out here pretty shortly. Hopefully before the next meeting. And then in the chat space, we looked at in the chat space, we looked at Discord and Telegram. We did attempt to find something that would do both email and chat, and we really didn't find anything that did them as well as these two individual platforms. So that's where we've ended up. We're going to recommend Discord, and we've got a guest Discord server that we used for. And by the way, you can, for those who don't like the black look of Discord, you can get a white look. So some people prefer it different ways. And so we've been, experimenting with different ways of putting in. So I've got a test Discord server set up with categories. And anyway, just to say that the comms team did what I think is a pretty thorough evaluation and selected those two platforms. Where we're at now is we need to decide on the policies for them. So like, how open are they? Like, can anyone just join them without even any kind of approval? What do we do about current members of the list, the DPRG listserv? Questions like that that we need to close on. But I hope to have them in place by the next meeting. So keep an eye on your DPRG list email, because we'll be publicizing there, and Robot Night, Builders Night Virtual, and any other ways that we have of reaching people to when we activate these things, and try and provide what was asked for at the meeting, which was ways for members to contact one another. Okay. With that, let me throw the meeting open for discussion. Does anyone have any thoughts they want to bring up? Questions, suggestions?
So are we keeping Google Meetup, or is that going away? Or?
The question is, do we know why the list server failed? I do not. There's probably a host of reasons, because some people may not be subscribed. Some people get server errors when they go to the page to try and adjust their settings. Some people just plain can't log in. There's a whole. I've been involved in 3, maybe 4 people who've had problems. There's a couple of people who have wrong email addresses in there. There's probably a variety of problems, but I think the bottom line is, is that maybe we could work through all of them and make it work again, but it will still be an old listserv. It will still not support pictures embedded in a modern way, previews of web pages, the way modern, it's old. But
one of the things with the listserv, some people email, or should say, some people internet providers offer different levels of security, which interferes with broadcast email. And realize, I think that's part of the problem. Otherwise, experience. So
the short answer is no, we don't.
The answer to that is you can't really fix that.
Well,
yeah.
No, because it's not an email server. It's a totally different application.
Yeah, I was blocked. My IP address recently got changed, and that fixed it. But so I have an IP that's forever, at least.
Yeah,
Years old.
Everybody could whitelist. Everybody could whitelist the DPRG. That should solve that problem. But I honestly can't tell you how to set up the whitelist for all the different mail clients that you guys are using.
And honestly, I don't think there's much point in looking backwards to a listserv that was built in the late 80s, early 90s, before modern web standards were used and before HTTPS became what one should use on the web. It still uses HTTP. I think we need to go with a modern solution, and that's where we're going in the email space. And the team believes that we need to retain email because it's the only way, it's the most assured way of reaching people. It still won't reach 100% all the time, but if people don't read their email, then you can probably only reach them by phone, SMS, or maybe in one case, LinkedIn. I was anyway. The other thing that we're introducing, though, is a lighter weight chat because we felt there's benefits to being able to chat in an informal way. It's a more modern interaction. It's kind of like everyone switched to using SMS. People don't call each other so much anymore. So we're going to enable that. I hope it's successful. We have no guarantees, but we're going to give it a shot. But it's a lightweight, chat on whatever topics. Any questions, thoughts on that? Anything else that anyone wants to bring up? Anything generally? This is a discussion session before we roll on to Robot Show and Tell.
I'm still blowing my mind how to do 5 spots for the Robo contest. Because I look back in all the what I thought was all the records, and I didn't remember seeing 5 spot in the last 5 or so years.
Right. There's not, we tried it one time. One time. And like I said, even when we started this discussion on Robo-Rama, I said, come May, if nobody says they're going to run, we won't run. Now, if there's one person who says they'll run, then we will run. But, it's not, it is a little more complicated. And, like in your case, Mike, you've already kind of got a robot that you think is. Okay. So now you're looking for more chance. So 5 spots is excellent way to go on the next spot. Now, so let's look at this room where it is right now. Okay, everybody? Okay. All right. So there would be the center spot would probably be right here.
All these chairs.
That's the whole point.
For you, yes.
Really?
Each corner would be made clear. Otherwise, what I'm saying is, this one's okay. If you look at the size of the corner that you have to put your robot in, this one's okay. I don't know if this one would be very challenging, and we might move some stuff to make it easy.
And we'd get power cords off the floor, right?
Okay. Well, we'll do, like I say, we'll let everybody run the first time and see how it goes. And then we'll simplify the room to make it easier until all the runs are used up. That way, because the intent of all of our contests are initially make them fairly simple. And then as everybody can do that problem, to make it a little harder. So like in that corner over there, it's clear, that'd be less clear. And that one over there, technically be less clear. So we would, only place we might move something would be this corner.
Yeah.
And then the rest of it, and like I say, I said it would be in here. I guess technically it's in the middle of there, but we would move the center spot to some place that was clear.
Yeah. That Andy is perfect robot right there.
Hey, so just on that thought, just not to stretch this out too long. If you had some technology that can map the room, let's say,
There's no restrictions on this.
okay, so I could map it with that device using more fancy room mapping capabilities. And if I could access the database correctly, I could then use that to
drive my robot.
What if
Yeah, I mean separately, like.
Well,
pre-map?
in other words, yeah, pre-map it, you know, it has to
How
do
do
it
I
on the
know it's
fly.
gonna be, okay, you can pre-map it before we adjust the group.
I mean, after the adjustment, it has to be the
Because you
robot.
have like a few minutes.
But I guess I could put the headset on the robot and let the robot drive the headset.
Because basically, it's not marked until an hour before the contest. And then you got a couple people trying to map it.
Well,
I'm just saying,
I won't waste time.
Yeah, you're really good politicians at it. Pretty good.
Yeah. So like if we like to see things that are like, there's a dying to see, what you're gonna do with your 3D, put it up inside and make it.
Well, the Quest does, inside out, it does, even walking around the room, that's the only, obstacle. It's pretty, and it's no basic, all done with cameras, yeah, and maybe that.
That sounds like fun.
Yeah, I don't know, I'm just talking, okay, I'm shutting up because
I like the legs of that thing.
is it gonna happen? Yeah,
Legs of that thing would be really difficult.
I think the bottom line is like Doug said, if someone's wants to run in it, then we'll run it.
But you know, the second week of May says.
Yeah. Then we won't do it, obviously.
Hope that anybody can make progress on it next time. But, yeah. Well, I think, you know, we could have another contest.
There's some questions online.
Oh, okay. Questions online?
Yeah, so, the first is that, Ray asked if we're keeping Google Meetup. So I think there's Google Meet and then there's Meetup. So do you want to comment to both of those?
So
I guess we're actually using
Google Meet is the video system that we use on Airbnb. There's Meetup, which is a whole different thing for making connections. I don't know of a Google Meetup.
No, but I think Ray might have meant Google Meet.
Oh,
Yeah, I did.
yes. We're going to keep.
We're talking to both of them
Right,
now,
right. So we're going to keep Google Meet for meeting at Airbnb, for monthly meetings, sharing online. That was outside of the scope of what the comms team was asked to look at, which was how do we make it lower friction for members to communicate with one another and stimulate conversation, make a community easier for people to interact with. So yeah, Google Meet stays the same. So it's really just replacing the listserv with Google Groups and introducing a Discord as a chat platform.
And then Arun asked on Discord, is that for general purpose chat?
Yeah. Well, I mean, what does general purpose mean? I mean, you know, we're a robot club, you know.
So we have private channels for the board discussions, right?
Yeah.
And then there's public channels for different topics, there's general topics.
Yeah.
No, it's just a general purpose Discord chat tool, I think.
Yeah. And it's going to be open to everyone that is like in some way DPRG related, friends of DPRG, etc. Probably not going to invite all of the DFW Metroplex to use it for their personal business, but you know, if it's sort of, you know, in some way related to DPRG, that's fair game. Yeah, absolutely. Except for John. Anything else from the web, Carl?
That covers it.
Okay. Any other discussion points that anyone wants to bring up?
Last Tuesday, I was whining about my, climate light sensors and how they must be broken. I mean, they're not broken, but they must have some sensitivity to movement. And then Carl said, make a real simple test setup and check it out. And I made the test, I made the setup, and I went, well, I'm not seeing it. Must be doing something wrong. Tried, moving my robot and watching the depth and plotting it out. Yeah, I take all the sensor data and put it in a spreadsheet and plot some of the columns. And it works good.
I know it works.
The sensors work good.
Oh, okay.
Yeah.
So you're not seeing that kind of lag or whatever we thought you thought?
So
I'm not talking about lag, I'm talking about when I moved.
When you moved, it was like 2 bars.
Yeah, it was like, do a heavy bag to reset. But when I plotted it out, it's like, okay, it stopped, then it moves, then it stops. So basically, it's at one distance, and then when it starts moving, it's a nice linear moving line, and it stops. Independent on what speed I run. So.
Oh, so it's doing just what you'd hoped it
So
should.
this is a point, like spot, like static directional spot.
Right.
Distant sensor.
Right.
What sensor just that we
So the background for the people who weren't at last Tuesday's Airbnb is John, Mike reported and showed us actually that when his robot started moving, the spots that the time of flight sensor reported as being wall moved away from the robot when it started moving. And we were all like, what?
Would be like stay on the wall. And
Yeah.
move. And when I stopped, it go back to the wall.
Yeah, very strange.
So,
And so,
I'm not sure what that is, but it's not the same. So it has to be delays and lag and kind of loss.
Okay. Interesting. Thank you.
Yeah.
what
That
type
is-
of sensor?
It's an 8x8 time of flight sensor. And it's a DL53L5.
So you're saying that the sensor you can trust now, but something after the sensor to whatever you saw, that problem's still there.
And it's not the serial port because I had serial port data out.
Okay.
Yeah.
So you're still on the
Then you go to serial, then you go to a ROS topic, and something else into a ROS topic, and works on it. And merges it with a
Power supply problem?
no, it merges it with a transformation of what the robot should be, like the coordinate of it, and that
So
kind
you've
of
got all
stuff.
this magic black box stuff.
Right.
I mean, no good data, and then that's weird.
And those points on the screen.
Yeah.
So good luck taking the sensor without driving the robot with physical motors and move it, do the same thing. We just took a robot. Do this.
Oh, I did the test where I drove the robot.
Yeah,
The
but
sensor on it,
Right.
and they work perfect. But it's not using ROS or anything.
oh, I see.
I just took the serial cable out of the.
I see. Okay, so you know this.
And then plugged it out.
Doug, did you have something you wanted to say?
I'll look it up here. I just recently did a review on some anyway sensors. The very smallest one. It actually Benaway just dropped the sensor, but it's still available. A real tiny. I'll look up the name, but I think one of the things I found was distance reported correctly the color of the target. The target color changes the distance.
Really?
So,
Wow.
so I'm just saying that it's going from like a white one to a black one.
Oh,
Whoa.
And I think it's because it uses probably uses an LED for the light source. I think. I don't know, but I'm just telling you that
Wow.
it's something to consider if you're starting to get some weirdness. To take a look. Now, like I say, anywhere not selling this, but it is available on Amazon and other places, and it's inexpensive. So, you know, people at first blush would often say, "Well, that looks like a good deal," because you know the range is nice. You know, the speed is nice, and it's very consistent, and it's not a bad sensor. It's just got some weirdness to it that you got. You know, the usual weirdness is you just don't get readings. This one all reads. The problem is the distance they report not necessarily the exact.
Right.
You know, we used to time of flight sensor to be within 2 or 3 millimeters. This is probably between 2 and 3 inches.
I have something I want to bring up. If anybody here or anyone watching the video afterwards does Facebook, I'd like to ask that you follow Dallas Personal Robotics Group on Facebook, and maybe even like some posts that come up, because I'm trying to use that as a channel as an outreach channel to bring more awareness of the club to a broader audience. So that's my request. Anything else in the discussion? Yeah.
Mark my can with this tape, which is a 3M brand, orange, and notice it's getting real low. New roll. I used the actual number of that was in the instructions for the
little different color.
and completely different color. Yeah, and so you need to calibrate your block sensor with this tape, not this one from
Okay.
I gotta go back.
Voice of
I
experience.
gotta put it on and see if it works better now. Because my robot, it was having a hard time seeing the can sometimes. It's got a lot of natural light in my room. It changes all the time. So I switch lights on and off. They work sometimes, it doesn't work other times. They used to make it look better, but then I got to go with Rob's suggestion of while you're doing blob matching, do blob matching with different shades of the color and get the best one. Great, yeah. I just wanted to show.
Cool. Yeah.
So Doug, did you use duct tape?
I should point out that Robot Columbus, because some of our cones are older than other cones, are a different shade. And if you buy them, for some reason, the newer cones are now becoming totally different orange than the old.
Which one?
It's a third shade. I'm just saying.
It's brighter and more yellow. It's more like the bottom one on my eye.
Interesting.
I'm seeing some really saturated.
All right. Well, if there's not any other discussion items, I propose we move on to show and tell. And I want to nominate Eric to go first because he's got the grandest, most impressive looking robot. And I'm going to turn this microphone off. Oh, yeah. Great idea.
Yeah. If he brings it up to the front, we have the cameras. So
Great.
it's
Yep.
Early feedback from online is that this wireless hotel makers are doing a great job.
Oh, really?
Yeah. We might have to put the hook for work.
Yeah, let me try to do that.
Yeah, let me get a.
Hi, can you hear me?
You got that, Mike, right up against your.
Yeah, I know. It's like, I think it's just,
Yes.
hang on. All right, so this is my robot for the 6-can competition. Essentially, I've taken a bunch of Lego bricks and built the outside chassis for the robot. It has a couple things on it that are new. I got a new camera for it. There's actually a Razer Stargazer camera, which has been discontinued, but the internals are RealSense D300. So the drivers that work for that will also work for this. And they have an open API, so you can connect to the camera and get the data off of it. So the camera does the RGB plus the depth sensing. So something like an Xbox Connect. Other than on here, there's a Windows computer. So it's just a simple Windows 10 box with a 1.2 gigahertz computer, and that runs the Vision software that runs on here. I'm using AForge, which is a C# port of OpenCV. And then also they have an API that's C# to talk to the camera. So basically the way the program's run right now is I'm using the blob detection routine to figure out where the color's at, gives me a middle point. I can feed that middle point to the API for the camera, and it will give me a depth about how where that point is on the screen. Other than that, there's a claw on the front here. So the claw is basically set up with a little bumper here. And this is primarily for feedback for the program. So when the claw closes, this bar gets pushed back and held in place. Therefore, the robot knows it actually has that can in there. It's not used to detect the can because the can's so light, it just kind of pushes it along the ground. But when it closes it, then it has the feedback. And essentially, the robot is kind of blind for about a foot before it can get the distance on it. So once it gets there, it'll go slowly and then just guess and grab it. And hopefully it's gotten the gripper for that. It's a little blind for that last foot on the sensor. Everything else here is running these Mackinnon wheels. So these are these omnidirectional wheels. So I can go forward, backwards, side to side. I can crab walk it and spin in place for the robot. Primarily during the competition, I'm going to keep the robot facing forward. So it'll go forward, side to side to track it. Once it has the can, then it can spin around and then go back to the goal and drop it off. Current plan. I am going to try and get some SLAM working on here too, because I got to figure out, of course, where the other robot is. Right now, it has no idea. It just knows where the can is and where the goal is. But if it hits the other robot, it doesn't know. That was 2 robots on both sides.
No, just one robot on 16.
Okay, cool.
Hand soccer, just two robots.
Okay, are we doing both competitions or just the one?
We're just gonna have one
Okay,
this time. Okay.
all right.
Made the job easier.
Yep.
Unless you want to build 2 robots and run your own campaign.
All right. Okay, any questions?
When you're moving sideways, do you have obstacle detection or sideways mode?
No, I don't.
So, you like keep a track of where you are in the arena, so you know you don't like crash into the sidewalls.
At this point, no. But I probably have to put some tracking with the odometry or with the camera to figure out where the walls are at on that. But at the point I've written the code, it's just looking for that middle section for the can, and it's going to move forward and grab it, and then spin around and come back, and hopefully it's not going to hit the wall. Yeah, it's something to definitely look for. And with the addition of the 3D camera, then I can do that actual SLAM tracking and see where the walls are at, and hopefully have a better accuracy.
So, are you gonna try to do 5 spot? We talked about it.
I know. I didn't even know that was a thing till now.
Oh, okay. Yeah, because you look like you have the camera in the depths, so you can probably even see the legs of that projector.
Right. And the camera's pretty accurate. The camera's actually designed for face detection from your monitor. So it's a very close range on there. Whereas like if you put like an Xbox Connect, it has to work like 5 feet away. This is a very short range IR sensor.
How does your odometry work?
I've got 360 degrees of accuracy on the encoders.
A motor encoders on the Mackinnon wheels.
Right.
That's that?
So are you using Lego drive or are you using to drive your wheels?
Yeah, there's Lego motor controllers in here. So there's a buck converter down here that takes the power from the battery pack and distributes it across all 4 motors with the same voltage. And then that goes to a motor controller, then it runs the system. And that's all controlled through the Lego NXT controller on there. The computer itself does use Bluetooth to talk to the controller. So when the camera figures out how far away the object is, it'll send the Bluetooth and tell the motors to go forward and control it that way. And that's basically it. Oh yeah.
We'd love to see this.
Yeah. Yeah.
No pivot.
Yeah. So no forward and backwards. Oh. What? No.
Demo.
Oh, hang on. I was going forward and backwards.
You know what I'm saying?
Is this die? Oh, there you go. Okay. So forward and backwards, you go side to side. So crab walk. And of course, you can spin in place. So my basic idea was during the competition, I was going to keep the robot facing forward. I was going to track the can, go side to side, and search for the can, and then go forward and grab it. Then once it has it in the thing, and then just have it go ahead and do a turnaround, and then basically when the camera looks at the field, I've got a white wall around it, and I got two black ends. So then it's going to use that color change to figure out where the goal's at. And then go back, drop it off, and then just near 360 until again it sees the other side of the arena, which would be the black area to align itself.
If you command it to turn 90 degrees, let's say, or maybe turn it another 90, how close can you come?
It's just the odometry again. I have to count how many ticks it takes to go around in one circle and kind of guess.
And pretty much affect a fairly reasonable.
Yeah. Yeah, so I can count all the rotation on the wheels. Okay, so it gets here, then stop. And
Done this to see how accurate it is with mechanism on different floors.
it's not very accurate at all. It's gonna be very general, and I'm depending more upon figuring out where the wall is that the camera can see to align it. So I can get a straight line based on where the wall's at, and that will tell me where the alignment is.
Some gyro or something would really probably help.
Yeah, and actually the API for the camera has a whole thing for wall alignment, so you can tell it to tell me what the angle is of the wall it sees.
And am I right in thinking that the carpet that the room will be running Roborama in is carpeted?
No.
No, okay. Okay, so it'll be like this.
Yeah.
Okay, so practice in this room will be representative of.
The gray,
This is rough epoxy floor, and the other one, last I saw, is the fake wood plank.
yeah.
And neither one of these, I think we can assume, is actually
Flat.
uniformly flat. So as I was able to demonstrate with the mechanism that I had, you can easily find spots on the floor in the other room where where the robot would sit still, but two wheels would spin.
Mhm.
Yeah.
Yeah.
It kind of throws off odometry when that can happen.
Yeah,
It would be interesting. It counts revolutions.
Yeah, Carl, it'd be interesting because this robot, because it's.
This Lego, it's got a flexible base. You got some natural suspension in there.
right.
Nice.
Yeah.
Yeah, but it doesn't even have a nice flat surface. Otherwise, it's going to skip and have alignment. Yeah, so depending upon the odometry is not going to be a very good option. But just for a general, gross movement, you can use that.
So it might be an argument for a three-wheel.
Oh, yes, because then you would have the four-legged table, right? All three legs would always touch.
Right. Yeah, but you have a different type of wheels.
Those are the three-legged omni wheel.
Yeah, they do. Yeah, you kind of ones where they've got the wheel straight and then they're horizontal. They're cut that way.
Always straight.
Yeah.
One wheel pretty much is always straight.
Right. Yeah, but that one you have to have a triangle to make that work.
One wheel off. Let's just take the wheel off. Thanks, Eric. Good idea.
Let's see.
Who else is going to robot? Tom's going to robot. I've got one. You know else? It's all right. Sure. Yeah. Here. We'll let you end up, Paul, because you got. Yeah. All right.
I can do the camera for your show and tell, Doug.
Oh, you want to make a?
Oh, I like that. Yeah. That okay, guys?
Say something, Doug?
Yeah.
Yeah. Okay. All right. Let me get this guy. Okay. Now, people who this is an old robot design, so a lot of the club members have seen it. I'm not going to go through, but there are people here who haven't seen it, and so I wanted to. This robot with this front plate was the 2016, so that's how old we're talking. 10 years now, 8 years. Robot design this was, and one of the things that I think that people who haven't seen it might be intrigued about was the design philosophy on it. There's a few things that you try to do with a robot. On this one, if you look at the bottom, you can see that the wheels are all made in a mechanism that allows them to be exactly aligned with each other. All right. So that's actually, so there's this motor chassis, if you want to call it. Then if you look at the front and back, there's a line where the robot is cut in half. So there's a back side and a front side. And the intent was to allow the back side to not change once you establish your motor control and your basic logic processor, your display, whatever. And the front was meant to be customized to whatever your function was. It also has a handle, which is easily incorporated into it. And there's a base to it, which if you haven't built a robot yet, one of the things you want to first do is get yourself a stand. It can be a book, but you got to have a stand. So this particular one approached 6 cans in a slightly different manner. You can see it has a gate. The intent was, there's also right here, there is a beam, infrared beam. So when the can enters this region here, it breaks the beam. That causes the gate to close. Now, this is done so that now you can go to maximum speed, and if it falls over, no big deal. You know, it's still trapped. All right. Now, is this better than a claw? Probably not. It's just a different approach. Okay. This is a Pixie cam, which is a blob detector. But probably the cool thing about it is it has its own separate processor, which is Pro Mini, I think, an Arduino Pro Mini, which is so just a basic little 8-bit processor. And this processor essentially takes the information from the camera and turns it into a single bit. And it spreads between the character, what would you call it? It's not the character, the value 40 and the value 120. So, you know, in your character, you've got 0 to 255. So you're using the 40 to 120, I guess. And there's a couple of characters out. So, but what that does is it splits the field of view into, which I forget exactly, each one I think turned out to be like 0.9 degrees. So when you get where the center of the blob is, it then translates that into a location, whether it's to the left or to the right. And that number, somewhere between 40 and 120, is returned. Additionally, another value outside of that range is used to report that it did not see a blob. So if you don't see a blob, you know, I think it's like a 30 or something. And then, but so that's all this thing does is take the information from the camera, turn it to a single bit, which it sends over. Byte. Thank you. A byte, and takes the byte and sends it over it. So it doesn't slow down the camera at all. And in this case, it's working on a Arduino Mega with a motor driver shield. It's using an UBEC for 5 volts control. It has a BNO 055, and if you notice the location, it's set exactly. That'll fall off. is in the center of the robot between the wheels. Now, does it need to be there? No, you can do all sorts of little translation stuff and all that. But if you put it in the middle, you don't have to do nothing. So it's a good idea to put it in the middle. Now, let's see, anything else? Okay. You asked, I want to show you the beam because I was kind of a little proud of that. You can go on Amazon, eBay, AliExpress, whatever you get, and you can get a little IR sensor, proximity sensor. They're less than $1 a piece, okay? And you can take off the receiver and the transmitter, and then you can see I put it in here and in here, and so I turned what would normally be looking out and back into a beam, so it just went. Now, these are really nice because they have their own comparator on it, so you get a real sharp, it's either a 1 or a 0. And that's, and you also have a little sensitivity thing, but that's almost any setting will work. So that's pretty much this. Now, so this is, like I say, a 2016 design. The philosophy was trying to, at that time, to put as many best practices that we knew. So there's some disadvantages to this robot. It was made with the intent to be goodish. Otherwise, it was supposed to be a beginner robot that people could build and grow with. Okay. But it's also a very sturdy robot. And because of that, it's also got some weight to it. All right. And the weight means that you've got inertia. So it was some of our better, as you push the speed envelope, reducing inertia is to your benefit. Because like this guy, he doesn't stop on a dime. Even braked, he doesn't stop on a dime. He's gonna overshoot. So that's something that you would consider in a new robot, how to make it lighter with the new materials. And the display on this one is a two line 16 character one. And there's a whole robot menu. Is there a battery in this thing? Yeah, there is. I didn't know there was. Let's see what happens when you turn it on. Okay. So it has, if you can see here, it just says DPRG Club Robot, owner Doug P. And if you push the next button, I guess it's the next button. Can't remember.
You can take a while. That's the problem.
Yeah, it's one of these. Okay, so see, you can see it has a system check menu. So if you select the system check, there's a sonar test. There's a scoop sensor test. That's the brake beam.
I'll stick my hand in there when it closes the jaw.
Let's see if I can get. Yeah, there's a gate servo test. Let's see. There's a camera test, and there it reports the blob location. Encoder test. You'd spin the wheel, see if you got. So this way, it's got an IMU test, so you could turn it 90 degrees, see if it really worked. And it goes, then you can go back to your menu. And then if you were really going to do it, you would go to the run menu. You would select run. It says it's waiting. So now it's basically cocked. You hit select and it goes 3, 2, 1 and runs. Well, I don't know what it's doing, but anyway, it runs. And then it reports certain things on the screen. The battery's probably, I don't know, like I said, I didn't even know what's in there. So anyway, That's an old design. But,
Just about the wheel space.
yes,
Because I had a wheel spacing parameter and I had like four digits to it. And I was noticing that when I did circles, it wouldn't, like the angle error would keep increasing. And when I was spun in the opposite direction, the angle error, well, where I thought it was actually versus where it actually pointed to. 'Cause when you're doing rotations, it's okay, rotated.
well, okay, the question is, are you really rotating? Or are you rotating and slightly skewing off of it? Or are you kind of dancing?
Wasn't dancing around.
Okay,
But, so I went in there and I recalibrated it, but I had to go to 5 or 6 digits of calibration between the wheel spaces, like the millimeters, like they're 240 millimeters is 240, 20, 0, something. And then finally it got to the point where I circle around and would have one or so.
well, that's part of the testing, I guess. Yeah,
I wonder how.
I've never had to use four places
Okay.
myself.
Yeah, just
Yeah.
oh, just odometry. Yeah.
Yeah.
I want to work really great with odometry. Of course,
Yeah.
slipping, no slipping.
Yeah.
And then, of course, I want to add a IMU to it to give an IMU into it.
Mhm.
That's the thing.
I haven't done this, but that sounds like the two wheels even though they're perfectly spaced, they're not the same diameter.
I do have a diameter adjustment too,
Yeah.
which is basically going in a straight line with the wheels supposedly at the same velocity,
Yeah.
which is enforced by the.
Have you done what's the name of it, Paul? Paul's not here. Oh yeah, Paul, what's the name of that square, that test? What's the name of it?
Borenstein?
Borenstein, yeah, okay. If you do the Borenstein square test, that will tell you which adjustment to fix. Okay, that's definitely worthwhile doing.
So the first thing I did is to make sure it drove as straight of a line as it could.
Right.
There's another definite with 4 decimals.
Yeah, but this thing, if you essentially repeat going like a 4 square,
Yeah.
and then you map your error points, and then from that that will help you correct for systematic errors.
Right.
It won't help, for non-systematic errors, it won't help, but that does work.
But I was just saying that to get rid of those, to reduce those systematic errors, I had to go to 4 or 5 digits. Like
I've never had to search myself.
4 digits out, and then they started to go straight.
Hmm.
And then the circle was the same thing, the
Yeah.
little spacing.
I tried to follow on this. One of Dave Anderson's things was, if you can fix it in hardware, do it. Otherwise, yes, a lot of these things can be overcome by fixing them in software.
Right.
But if your hardware is good, it makes the job easier.
Oh, yeah.
All right. But anyway,
That's why it's like 4 digits out to get it nailed down. That's the software. You
Yeah.
do that. Right.
okay, that's all I wanted to show. And I know this has been old for some of you. I might appreciate it.
Thanks.
So this is Pie Dog.
Were you the one that
Is this decapitation dog? Or?
Yes, this is Decapitation Dog. So last Tuesday at Airbnb, I was demoing him, and he fell off the table, and his head broke. The servo broke. Servo head broke right off of the body of the servo, and his head was down. And so anyway, let me see if I can get this thing going. Let's see.
Oh, so you got it.
Oh, this is your robot. Oh, that's good. No, Devon.
Yeah, I saw Ron's and I was like, "Ooh, I want one of them." And
So one of these things on Amazon, you have 2 hours.
yeah, pretty much.
2 hours. There it is on the porch.
Yeah.
With 3 of them now, we need the pie dog competition.
So,
Well,
you
that's
know,
three.
they really drive around. So I wouldn't be surprised if it's gone. Ready to go. Somebody.
Yes.
That's right. Or you start looking at something. You know, that's interesting.
But for those people who have seen the video that before,
He does push-ups.
By the way, describing the price of that.
Did you get his microphone?
No, not yet. And he's 6. So
invent that.
So he's got a Superman flying behavior. So when you pick him up, there's an IMU on the side of him, and when you pick him up, he goes into Superman flying pose. And if he had his tail, I stole his tail. I stole the servo out of his tail to replace the one that broke in his neck. And so he goes, "Pie dog."
Do that again. All right.
And then he's got a patrolling behavior where he patrols an area. So yeah.
Little insect.
And probably less expensive. I think I heard the number 100,000. So you could build these for awareness.
Hold on.
Yeah, it'd be expensive. It's broken, so he's barking. Usually not even.
I think his legs need some calibration. Legs are uncalibrated. And it looks like his head's uncalibrated too. Yeah. What's really fun is and I'm going to put him down on the floor for this. Is his trotting behavior. Actually, I'll let him. Yeah, I'm going to put him down on the floor and tell him to trot, because he's really gets along at a pretty good clip when you tell him to trot.
Oh, yeah. This is old.
Come on, come on.
Hey, that's cool. You know, hey, something that comes to mind, Paul. So, let's say you come across some quarter scale airplane server. You know, those things about the size of your hips. You could scale them up.
Yeah. Yeah.
I mean, really, even standard, whatever the little tree is that what a normal is? What's a normal server?
It's a kilogram server.
Can you make it? I know he doesn't. I know he doesn't. Audio do the how.
Sure. So he does have a howl behavior, but the audio doesn't work. So
We really appreciate it, actually.
Anyway,
What does Zoe think about this?
Zoe knows it's not a dog.
Yeah, that's probably true. The dog probably knows better than even like a child. That's not a dog. Dog is a good woman.
Why is it not working?
I got the competition. Got 2 fire hydrants.
Oh,
See every time they get
okay.
and yeah.
Well, there's a kid on YouTube that's anything like that. He had a Boston Dynamics star.
Oh, oh, oh. So anyway, that's all I got. That's.
I know. So how much is this?
Well,
I don't remember how much it was.
So it's like 170 without the RPi and the Raspberry Pi, and then you can put, I put a Raspberry Pi 4 with 8 gigs on it because I want to run ROS on it. So that adds another 60, 70 bucks or so. But it is designed to run on a Raspberry Pi Zero. So then you're only talking what, 30 bucks?
Yeah, but if you
Maybe have one in you.
Pi Zero should probably not be. It should be. If you had to kind of work for 2 months,
Well,
rather do that to have a better.
Ron, I would like you to know that for the ROS 2 workshop series that we ran earlier this year, I got ROS 2 working in Docker on a Raspberry Pi Zero 2W.
So I mean, as long as you don't have to do it, use it for doing anything itself, like compile failure and stuff.
So I'm just saying. Okay.
Oh, okay. I'm dissing something I don't know anything about. I'm probably dissing something that's been discontinued.
Yeah. All right. I think anything else?
Thank you for barking for us. I don't know what conversations we're having.
So there's certainly 4, potentially 5, right? Help me here, Doug. We got 4. Doug's going to read from the website.
So we're gonna have quick fit, 4 corners, 5 spot, and 6 cans. So 2,
Oh, so 3 for sure, 1 maybe.
4, 5 spot. Okay, 5 spot is, yeah. That's interesting.
Most of my single can soccer was
Okay, and the other one that we talked about, which is out, we're not on the website, is, where you go to pick things up and bring them back.
Object retrieval.
Yeah, object retrieval, and we talked about that, but we decided we weren't going to do that at the last meeting.
Said if anybody wanted to, they could. If you want to. Sample
Retrieval.
sample retrieval.
What?
I can't just the soccer without another person.
No, that's the one where you visit each corner in the center of the room.
No. The
6 can is where you have 1 robot and it's how fast it can clear the field.
Is it the same machine that we have can soccer?
Yes. Yeah. It's just,
I was just saying that the walls to be there.
How do you they're both logged into my cell phone hotspot. Okay, I think we come to the end of the meeting. Thank you very much for everyone for coming along and participating, joining us. And next Next meeting will be PCB design, how to do PCB design and get five boards for $2.
I don't.
All right.